We're on SAT Practice Test 10, Math Section 2, Question 1. When you get to Section 2, the first two questions are easy. They're so easy that you're going to think you must have blown Section 1 and ended up on the easy Section 2. An airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. What type of function best models the relationship between the descending airplane's altitude and time? For these kinds of questions, you definitely want to write A, B, C, D, and then you just want to cross off. So conceptually, what's going on here? This is an airplane, and it's going down. So if it's going down, is it going up? No. So what can you cross off? Cross off C and D, and then all you got to figure out, is it an exponential decrease or a linear decrease? Well, the key word here is constant rate. That's enough to get you to the answer, but if you're not sure, just think about it and kind of draw a picture. You're starting at 9,500, you're going to go down. How are you going to draw this line? You're going to draw this line like this, right? Or are you going to draw it like this, or how does it work? It's going to be a straight line. It's a constant rate. So, it's linear. It's a 2-second problem. You get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 2. What's the level of difficulty here? It's very easy. Remember that the first two questions on Section 2 are going to be so easy that you're going to think you bombed Section 1 and got the easy Section 2. Line K is defined by y equals 17 over 7x plus 4. Line J is parallel to line K in the xy plane. What's the slope of line J? So let's write down what we want. You don't even have to do this, but I want to write down the equation. Okay, so what's slope here? It's this. Y equals mx plus b. M is the slope. A line that is parallel to another line has the same slope. So line K has slope 17 over 7. What's the slope of line J if it's parallel? It's 17 over 7. B. Couldn't possibly be easier. One-step math, get it right, and move on. We're on SAT Practice Test 10, Math Section 2, Question 3. What's the level of difficulty? It's medium. Medium questions start on question 3 on section 2. Caleb used juice to make popsicles. An Able Testing Service is going to make a function about it. The function f of x equals negative 5x plus 30 approximates the volume in fluid ounces of juice Caleb had remaining after making x popsicles. Which statement is the best interpretation of the y-intercept of the graph of y equals f of x in the xy plane in this context? It's really important to write down what we're looking for in this question. What's the y-intercept? So let's just start by writing down the function, and let's label what the function stuff is. So what's x? ETS says that x is popsicles. What's f of x? Function approximates the volume of juice Caleb had remaining after making x popsicles. So f of x is volume juice remaining. Alright guys, SAT functions love 0 and 1. So if you're in a function on the SAT, you should think about real hard plugging in 0 and 1 into the function. Let's just try that out. Let's plug in 0. So if we plug in 0 for x, we're going to get negative 5 times 0 plus 30. And let's just run it. So it's negative 5 times 0, that's 0, plus 30, that's 30. So we get 30. So we get 30 juice remaining when we do 0 popsicles. Want to run it again? Let's try it with 1. Negative 5 times 1 plus 30. Negative 5 times 1 is negative 5 plus 30, that's 25. So what happened here? If we do 1 popsicle, we have 25 juice remaining. All right, what do you think the y-intercept is? It looks to me like the y-intercept is 30 juice when I do 0 popsicles. So I'm going to write that down. And then I'm going to go to ABCD and I'm going to cross stuff off. A. Caleb used approximately 5 fluid ounces of juice for each popsicle. Well, that looks like it's true, and a lot of people are going to keep this, so we're going to keep it for now, right? That's definitely true. You got 30 at 0 popsicles, 25 at 1 popsicle. Looks like he used 5 for each popsicle. Keep it. B. Caleb had approximately 5 fluid ounces of juice when he began. No, man. When he began at 0 popsicles, how much juice did he have? He had 30. So B is gone. C. Caleb had approximately 30 fluid ounces of juice when he began making popsicles. That's true. 0 popsicles, 30 juice. D. Caleb used approximately 30 fluid ounces of juice for each popsicle. Not true. 30, 25, looks like he's using 5, right? So that's gone. Okay. Make sure you answer the question. What's the question? What's the y-intercept? Y-intercept is 30. What's going on at 30? That's 0 popsicles. Caleb had approximately 30 fluid ounces when he began making popsicles. That's the answer. A is true, but it doesn't answer the question. Pretty sneaky, Evil Testing Service. C is the answer. You can get this right a lot quicker than it took me to explain it, and move on. We're on SAT Practice Test 10, Math Section 2, Question 4. What's the level of difficulty here? It's medium. And it's important to remember that it's medium, because if it looks really hard to you, it doesn't matter. It's medium. A physics class is planning an experiment about a toy rocket. The equation y equals negative 16 times x minus 5.6 squared plus 502 gives the estimated height y in feet of the toy rocket x seconds after it is launched into the air. Which of the following is the best interpretation of the vertex of the graph of the equation in the xy plane? So, very important to think about what it is we're looking for. It's the vertex. Let's start by rewriting the equation, and let's label what x and y are. What's y? It's the height. And what's x? It's seconds after launch. All right, I'm going to write A, B, C, D because I know I'm going to cross off. Best way to do this problem is just to go down and plug in the answer choices. A. This toy rocket reaches an estimated maximum height of 502 feet 16 seconds after it's launched into the air. So let's just run this equation with the numbers that we have. Y is 502, right? It's the height, equals negative 16 times, what's x? 16 minus 5.6 squared plus 502. You got to get out your calculator and do this. 16 minus 5.6, that's 10.4. You square it. You're going to get 108.16. You're going to multiply that by negative 16. And you're going to get negative 1730.56 plus 502. And you should be able to see that that's not going to equal 502. So A is gone. All right, let's look at B. This rocket reaches an estimated maximum height of 502 feet 5.6 seconds after it's launched in the air. All right, let's try that. Y, right, that's the height, 502, equals negative 16 times x. What's x? 5.6 minus 5.6 squared plus 502. All right, this is really easy because 5.6 minus 5.6 is 0. 0 times negative 0 squared is 0, and then 0 times negative 16 is 0. So it's 502 equals 502. Hey, that's true. Guys, that's it. That's the answer. Get this right very, very quickly. C and D don't matter because you plugged in the answers and you found one that works, and you move on. We're on SAT Practice Test 10, Math Section 2, Question 5. What's the level of difficulty? It's medium. The function f is defined by f of x equals 4x plus k times x minus 1. K is a constant. F of 5 is 32. What's the value of f of 10? So let's write down exactly what we want. This problem takes a few steps. You may be able to get away with doing fewer steps than we do here, but I want to show you enough of them to make sure it makes sense to you. A function is just evil testing service asking, can you follow directions? Can you follow directions? Awesome. Then you can do a function. Write down the function. F of 5 is 32. So what you got to do is every time you see an x, you're going to put in a 5. 4 times 5, what's that? That's 20. Plus k, we don't know what that is, times 5 minus 1, that's 4. All right, what's that supposed to equal? 32. So we got simple algebra here. 20 plus 4k equals 32. We're going to move the 20 across. It's going to change signs. 12 equals 4k. We're going to divide both sides by 4. So what's k? K is 3. Cool. So now we know what k is. We're going to run the function again for f of 10. So every time we see an x, what are we going to put in? 10. All right, so 4 times 10, that's 40. Plus, now we know what k is, that's 3. Times, or see an x, we're going to put in a 10 minus 1, which is 9. So it's 40 plus 27. And that's 67. Get it right. It does take a few steps. It's a medium problem. It's not easy, but it's definitely not hard. We're on SAT Practice Test 10, Math Section 2, Question 6. What's the level of difficulty here? It's medium. Triangles ABC and DEF are congruent, where A corresponds to D and B and E are right angles. The measure of angle A is 18 degrees. What's the measure of angle F? So what are we looking for? We're looking for angle F. All right, triangles aren't here, so you have to draw them. What does congruent mean? Congruent means exactly the same. And we know we have right angles. So we have two right triangles. Let's draw them as much the same as we can, but don't stress about it. B and E are the right angles, so we're going to put them on right angles. And then it doesn't matter where the other angles go as long as you put them in the same places. You just fill in what you know. Measure of angle A is 18. We're looking for this F right here. All right, if this is 90 and this is 18, 90 plus 18, what's that? It's 108. How many degrees in a triangle? 180. So 180 minus 108. Calculator math if you want. That's 72. 72 degrees right here. These triangles are congruent. That means they're exactly the same. How many degrees are at F? It's the same as what's at C. 72 degrees. So the answer is B. Medium problems are not hard. They just take a little bit of work. Get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 7. What's the level of difficulty? It's medium. We got two equations. Which point is a solution to the given system of inequalities in the xy plane? Guys, this is plug in the answer choices. All you got to do is plug in these x's and y's and see which one works for both equations. The best way to do this is to write down the answer choices. You don't need to write them all down. You can write down each answer choice one at a time, but make sure that you write down x and y because you don't want to get these backwards, which can happen. So A says negative 14 is x and y is 0. So let's just plug and chug, see what happens. Y, 0. The little one eats the big one, so is less than x, negative 14 plus 7. That's a negative 7. Is 0 less than negative 7? No. Don't need to do anything else. A is gone. B, 0, negative 14. So this time I'm doing the first equation again. Y is negative 14 less than or equal to 0 plus 7. Okay, that's true, right? 7 is bigger than negative 14. So now I got to do the second equation. Y, negative 14, bigger than or equal to negative 2 times x, negative 2 times 0, that's 0, minus 1. Is this true? No, negative 14 is not bigger than negative 1, so it's gone. All right, C, 0, 14. This time y is 14. 14 less than or equal to x is 0, so 0 plus 7 is 14 less than 7. It's not, so that's gone. All right, we got time. Let's do D. 14 and 0. This time y is 0, so we're doing the first equation. Y, 0, is less than 14 plus 7, 21. That's true. Checks out. So we're going to do the second equation. Y is 0 is bigger than negative 2 times 14. That's negative 28 minus 1. That's negative 29. 0 is bigger than negative 29. Hey, that works. You leave this thing knowing that you're right. Does not take longer or much longer than the algebra. You definitely get it right and you move on. We're on SAT Practice Test 10, Math Section 2, Question 8. What's the level of difficulty here? This is the last medium problem that you're going to see on the SAT, so enjoy it. The dot plots represent the distributions of values in data sets A and B. There's the dot plots. You want to read this whole thing to see what's going on. Which of the following statements must be true? And then you're looking for the median and the standard deviation. Let's figure out what we can about the median. You can kind of shortcut this on a real SAT, but it doesn't take that long to write out the numbers. Time me. That didn't take that long, and it's going to take you about half the time, because I'm writing on a computer screen. Do the other set. And to find the median, just cross off on each side. There's 1, there's 4, there's 4 over there, there's 2 over here, there's 2 over here. Median's going to be 13. And then over here, 2 over here, 2 over here, 4 over here, 4 over here, 2 over here, 2 over here. So the median here is going to be 13 as well. So what's the median in set A and set B? It's 13 for both of them. So there's kind of some cool stuff you can do here. Write down Roman numeral 1, Roman numeral 2. Write down A, B, C, D, and then just take Roman numeral 1, and let's see what's going on. Median of data set A is equal to the median of data set B. Well, that's true, right? So Roman numeral 1, we got to have that in the answer. A has it in the answer, B does not, C has it, and D does not. All right, that was the hard part of this question. Roman numeral 2 says the standard deviation of data set A is equal to the standard deviation of data set B. You do not need to know anything about standard deviation to get every standard deviation problem right on the SAT. All you need to know is that if the dot plots or the data looks exactly the same, then the standard deviation is the same. If it looks different at all, if it deviates at all, then the standard deviation is different. So look at these dot plots. Are they exactly the same? They're not. So the standard deviations are not the same. So 2 is gone, right? And that means that C is gone. And so the answer is A. You can get this problem right, you know you're right when you leave it, and you move on. Welcome to SAT Practice Test 10, Math Section 2, Question 9. It's the first hard problem on Section 2, and the rest of the problems from here on out are going to be hard. Got to read it, it's kind of long. A scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria, assuming exponential growth, which doesn't matter. The formula, that nasty thing, gives the number of bacteria in the growth medium. R and C are constants. P is the number of bacteria. T hours after the initial measurement. What's the value of R? All right, whatever you do, don't freak out. Always start by just writing the function. And then let's circle R, because that's what we're looking for. And let's label the things we know. We know what P is, that's bacteria. And we know what T is, what's T? That's just time. What do SAT functions love? SAT functions love 0 and 1. So particularly on exponent functions, always plug in 0 and 1 when you can. Can you plug in 0 here? Sure you can, because you know what happens at 0 time. What happens at 0 time? That's when it starts, so there's 12,000 bacteria. So P is 12,000 equals, we don't know anything about C yet, 2 just sits there. We don't know anything about R, it's what we're looking for, but we do know time. What's time? It's 0. All right, can't do anything with this 12,000. Can't do anything with the C yet. Can't do anything with the 2. But what's anything times 0? It's 0. So what's R times 0? Whatever it is, it's 0. So what goes right here? 0. All right, what is anything to the 0 power? It's 1. So what's 2 to the 0 power? It's 1. So that means that it's just C times 1, and what's C times 1? Hey look, C times 1, that's just C. So what's 12,000? It's just C. So now you know what C is. So let's run the function again, and what number should we use for the bacteria? The only other number we know, 24,000. Okay, we know what C is, it's 12,000. 2 continues to sit there. R is what we're looking for. What's time at 24,000? It's 4. I'm going to rewrite this to put R4, make it kind of in the order that you're used to, 4R. And then from here, it's so easy that it's hard to explain. What's 12,000 times 2? 24,000. And over here is 24,000. So you don't want this to change, right? So let's just kind of focus on 2 to the 4R. You don't want 2 to change. So what do you want 4R to be? You want this to be 2 to the 1. That's the only way to make it not change. So what's 4R? It's got to be 1. And now it's a very simple algebra. Divide by 4 on both sides. And you get R equals 1/4. You guys, that's it. That's the answer. It's B. There's some work to be done here. It's a hard problem, but it's totally gettable. Get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 10. What's the level of difficulty here? It's hard. A cube has a volume of 474,552. What's the surface area of the cube? So what are we looking for? We're looking for surface area. I've done this problem, this kind of problem, so many times that it's very easy for me. And if you'll just do this kind of problem a few times, it'll be very, very easy for you too. Just takes a few steps. First of all, what's a cube? It's a special kind of 3D figure. Why is it special? Because all the sides are the same. So you might want to draw a cube, make all the sides the same as much as you can, all right? And then how can you figure out the sides of the cube? You're going to have to get your calculator out on this one. And you're going to have to do this. Cube root 474,552. And when you do that, you're going to get 78. What's 78? The length's 78, the width's 78, the height's 78, every side is 78. 78 times 78 times 78 is 474,552. All right, the answer is not 78. You're looking for surface area. What's surface area? Surface area is like when you wrap on a birthday present, right? What do you got to wrap? You got to wrap the bottom. What's like the bottom? You got to wrap the top. What else? You got to wrap the side. You got to wrap the other side. You got to wrap the front. You got to wrap the back. And you've wrapped up the present. Right? So you got the front, the back, the side, the other side. What else? The top and the bottom. Just do one of these. If you deal with the front, it's going to be 78 times 78, right? So you do that on your calculator. You're going to get 6,084. 78 times 78. What's like the front? I already talked about it. Back, side, other side, all of these. 1, 2, 3, 4, 5, 6. So there's 6 things. They're all 6,084. Obviously calculator math. And when you do that, you're going to get 36,504. And that's it. That's the answer. The problem does not take nearly as long as it did for me to discuss it. You want to make for sure you understand it. And again, you do a few of these in practice. They're all the same. You can get really good at this really quick. We're on SAT Practice Test 10, Math Section 2, Question 11. What's the level of difficulty here? It's hard. You got two equations. The solution to the given system of equations is xy. What's the value of 8x plus 7y? So let's write down exactly what we want. Guys, this is simultaneous equations. How do you know? Because you got two equations. Simultaneous equations are always the same. You're going to stack them, and you're going to add or subtract. Let's save a step here, and let's just combine these terms. So 2 times 8x, that's 16x, plus 4 times 7y, that's 28y, equals 12. Negative 2 times 8x, that's negative 16x, plus 4 times 7y is still 28y, equals 12. It doesn't matter if you add or subtract. Put a line under them. I'm going to subtract. Why? Because it's going to make this juicy 28y and 28y go away. 28y minus 28y is just nothing, 0. Be careful here, 16x minus 16x, that's 32x, right? 16x plus 16x, 28y's are gone, equals 12 minus 12, that's 0. So what's x? X is 0. All right, cool. So now we know what x is. What are we going to do? We're just going to go and plug it into one of the equations. Pretty easy. 16x plus 28y equals 12. What's x? It's 0. So 16 times 0, that's just gone. 28y equals 12. I'm going to divide both sides by 28. I can't help myself but to reduce this. 12 divided by 4 is 3. 28 divided by 4 is 7. So y is 3 over 7. Okay, so now it's just 8 times x. Well, we know that's 0 plus 7 times 3 over 7. You can do all this on your calculator if you want. I don't care. But it's 3. Get it right. It does take a few steps, but it's definitely not that hard as long as you're careful. We're on SAT Practice Test 10, Math Section 2, Question 12. What's the level of difficulty here? It's hard. A certain town has an area of 4.36 square miles. What's the area in square yards of this town? And then Evil Testing Service helpfully tells you that 1 mile is 1,760 yards. Exactly what do we want on this question? Let's write down that we want the area in square yards. Where's the town? It's not here. Let's start by drawing a picture of the town, which doesn't have to in any way be to scale. There's the town. What's the area of the town? It goes inside. It's 4.36. 4.36 what? Square miles. I'm going to go ahead and write down that 1 mile is 1,760 yards. There's a bunch of different ways to do this problem. The easiest way is to plug in. So guess what I'm going to do? I'm going to plug in. And you should too. It doesn't matter the dimensions of the town. You can make the town look as weird as you want. Let's make it weird and easy. Let's just make this 1 mile. And if this is 1 mile, then how many has to be right here? 4.36 miles. Because sure enough, 4.36 times 1 is 4.36 square miles. So really weird shaped town, doesn't matter. Now let's convert 1 mile to yards. What is it? It's real easy. It's 1,760. All right? Now let's convert 4.36 to yards. Got to use your calculator on that. 4.36 times 1760, and you're going to get this number, 7673.6 yards. And this is yards also. So what do you do to find square yards? You just multiply this thing times this thing. Already got one of them on your calculator. When you multiply 7673.6 times 1760, you get this exorbitantly large number, which in the event of a real SAT, of course, you just look at, figure out what the answer is, but I'm going to write it down. There it is. The answer is obviously D. When you plug in, you leave this problem knowing you're right. You didn't run into any of the mistakes that are A, B, and C here, and you know that ETS made those mistakes for people doing algebra. You get this question right quickly and efficiently, and you move on. We're on SAT Practice Test 10, Math Section 2, Question 13. What's the level of difficulty here? It's definitely hard. A lot of people are going to find this stupid hard, but those very same people are going to be people who refuse to draw the figure and who don't plug in, not you. All right, what's really hard is reading this problem. I apologize. Triangles PQR and LMN are graphed in the XY plane. Triangle PQR has vertices PQ and R at 4, 5, 4, 7, and 6, 5, respectively. Triangle LMN has vertices LM and N at 4, 5, 4, 7 plus K, and 6 plus K5, also respectively. K is a positive constant. The measure of angle Q is T degrees. What's the measure of angle N? Okay, guys, it's a plug-in. How do you know? Because the answer choices are crawling with variables. Secondly, this figure is not here. So what do we need to do? We need to draw it. If you think for just a second, it's an XY plane, but what quadrant matters? Only the top right, because everything's positive. So you don't have to draw it to scale, just do the best you can. The first point P is 4, 5, so 1, 2, 3, 4, 1, 2, 3, 4, 5. All right, what's this right here? That's point P. All right, what's the next one? 4, 7. Notice it's on the same thing. It's on the same line. 4, this is 5, 6, 7 up, right? So what point is this right here? It's Q, and then R is at 6, 5. So we're going to go over 2, 5, 6, and it's on the same thing, it's on the same line here that P is on. So this is R. So let's draw our triangle. And let's note, do we have any kind of triangle that's notable here? We do. This is a right angle. Okay, now let's do LMN. So LMN is at 4, 5. Hey, look, that's the same place. 4, 5. So in addition to this being P, it's also L. 4, same here, 7. There's 7 plus K. So I'm just going to go out here on a dotted line. I don't know what K is, so I'm going to make that K. All right? This right here is what? What point is this? It's M. And then N is 6 plus K. All right, so again, there's 6 over the same basic amount. K. What point is this? It's N. And then let's look at the little beautiful figure we've drawn. It's like two triangles that are the same. They're both right triangles. One of them's bigger. All right, what is the measure of angle Q? Where's Q, first of all? It's right here. It's T degrees. We can plug that in. What do you want it to be? Make something nice and easy. Let's make T degrees equal, how about 30? Because that is really, really easy. That's 30 degrees. If that's 30 degrees, we're looking for angle N. We're looking for this guy right here. Should have said that from the outset. Is this angle here, right, the same as anything in the small triangle? It's the same as this guy right here, right? What is this angle right here? Well, this is 90, this is 30, 120, 180 minus 120 is 60. That makes this 60 degrees, and that makes N equal 60 degrees. So when we go down to the answer choices, what are we looking for? We're looking for N, 60. I go down, and then I run into this problem. It's like, oh man, K's in the answer choices. Well, think about it for a second. What is K? First of all, it's part of a side of the triangle. Now, do sides of triangles have anything to do with angles of triangles? I mean, they do, right, proportionally, but what about in terms of the numbers? They don't. It doesn't matter what K is. You can't really plug in for constants. But in this case, I'm gonna, because it doesn't matter what it is. So I'm just gonna throw in K. I'm gonna say, well, this doesn't really matter. It's just a side extension. I'm gonna make it 2. All right, so if K is 2, this is 90 minus T minus K, 30 minus 2, 90 minus 28. Okay, you can ballpark that. Is that going to be 60? No. B, 90 minus what? T plus K, so 30 plus 2, 90 minus 32, and you can ballpark that. Is that going to be 60? No. C, 90 minus 30, right? T is 30. Is that going to be 60? Hey, that's 60, so we're going to keep that one. And this is 90 plus K. That's 92, or whatever we make K. Doesn't matter. not the right answer. C is the right answer. You can get it right. You can get it right a lot quicker than it took us to go through this problem, although it does take more time than an average problem. And you move on. We're on SAT Practice Test 10, Math Section 2, Question 14. What's the level of difficulty here? It's hard. A small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain discounted pricing. If the owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles, what's the maximum number of large candles the owner can purchase for the discounted pricing? So exactly what are we looking for here? Let's write it down. We're looking for maximum large. Guys, if you came here for algebra, I guess I got good news and bad news depending on how you look at it. You do not need to do any algebra to get this problem right, and you shouldn't. Just figure out what's going on. How many candles is it? It's 200. And we know that it's either going to be large or small. The large are $11.60. The small are $4.90. I'm going to label those. In the event of a real SAT, you could probably get away with not doing that. And let's just say it's 100 of each. See what happens. Kind of get a baseline. Maybe it's right. You're going to get out your calculator. 100 times $11.60. That's 1,160. And then on the right side, $4.90 times 100 is 490. So you add the two numbers up, and you're going to get 1,650. This is obviously wrong. Why? Because we got 2,200 to spend. We only spent 1,650. We should get more large candles, right? We're trying to maximize that. So let's jack it up. Let's go 150. It's 150 large candles. How many small? 50. So 150 times $11.60. That's $17.40. And 50 times $4.90. $245. And again, you just add them up. It's $1,985. Think we can spend more? Yeah, man, we got more money to spend here. So let's keep going. Let's jack it up some more. Let's say 180. It's 180 large candles. How many small is it? 20. All right, so once again, back to our calculator. 180 times $11.60, 2,088. And then 20 times $4.90, $98. All right, so we add them up. 98 plus 2,088. Pretty close, man. $2,186. All right, what do you think? Want to squeeze a couple more candles here? Let's see. Let's go to 182. But it's 182 large. Obviously, what? 18 small. So back to calculator. 182 times $11.60 is 2,111.2. 18 times $4.90 is 88.2. Add them together. It's $2,199.40. What do you think? That's pretty close, right? If you want to keep going, go ahead. I am very confident that it's got to be 182 candles. That's the right answer. This doesn't take any longer than doing the algebra. You're not going to get lost in the algebra that you create, and you're going to leave this problem absolutely certain that you're right. Get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 15. What's the level of difficulty here? It's hard. A square is inscribed in a circle. The radius of the circle is 20 root 2 over 2. What is the side length of the square? All right, where's the figure? As usual, ETS describes it, but doesn't show it to you. So you got to draw yourself. My advice is always to draw it kind of big. Draw a big old circle. Inscribed means touching, so you're going to have the square touch the circle at all four corners. The radius of the circle. All right, that's not the diameter. It is a line from the center out to the circle. You can draw any radius you want, but when you have two things like a circle and a square, you want to try and connect them somehow. So how can you draw a radius that connects the circle and the square? There's four ways to do it. Draw it out to one of these corners here. You draw it to any corner, it doesn't matter. All right, what is this length right here? 20 root 2 over 2. And finally, what are we looking for? We're looking for one of the sides of the square. Guys, this is a special right triangles problem. And you really want to be looking out for special right triangles problems when you're on geometry on the SAT, particularly on harder problems. You don't need to memorize special right triangles. It'd be a lot cooler if you did. They're in the formulas box. You go to them. If you don't have them memorized, you look and you say, hey, which one is it, right? First of all, where's the triangle? In order to make a triangle, you're going to have to extend this radius and make a diameter. And you say, all right, well, which one is it? Is it the one with 3 different sides, or is it the one with 2 sides are the same? It's obviously the one with 2 sides are the same. So it says it's s root 2. All right, I'm going to make it x's. I'm going to make it x root 2. All right, and then what are we looking for? We're looking for an x, right? We're looking for a side of the square. Okay, x root 2 is the diameter. And what's the diameter? It's twice the radius. So you got to say 2 times the radius, 20 root 2 over 2. I'm going to put this 2 over 1 so I can just see that those 2's can go away. I can reduce. And what's the diameter? What's this line right here? It's 20 root 2. All right, what is the diameter as well as being 20 root 2? It's x root 2. So x root 2 is 20 root 2. And I suppose you could do like 5 steps of algebra here, right? But what's x? X is clearly just 20. X is 20. That's it. That's your answer. It's A. These problems are really easy once you do a few of them. So if you're a little bit confused here, don't worry about it. Just do a few special right triangles problems and you'll see that it's really just kind of plugging and chugging. Get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 16. What's the level of difficulty here? It's definitely hard. A lot of people are going to find this to be crazy, stupid hard. But it's not that bad if you just draw a picture of what's going on. Which of the following equations represents a circle in the xy plane that intersects the y-axis at exactly 1 point? This is not the picture we're going to draw, but like what's happening here? Here's the xy axis. It intersects the y-axis, that's this one, at exactly 1 point. So it's going to look something like this. We're going to want to cross off answers here, so we're going to write A, B, C, D, and we're going to want to draw a big old xy axis. We're also going to need the circle formula. It's not in the formulas box. You got to know it or put it in your calculator. It looks like this. The x and the y don't matter. The h, the k, and the r matter. The r is the radius, so r squared is radius squared. The h and the k are the center of the circle. So in this little circle here, there's the center, and the h and the k are the x, y coordinates of that center. What's the radius of the circle? Well, we look at the answer choices. It's 16 in every answer choice. It's radius squared. So the radius of this circle is 4. We look at answer choice A. What are h and k? They're 8 and 8. So let's just draw that out. 1, 2, 3, 4, 5, 6, 7, 8. And do the same thing on the y-axis. We're going to put the center of the circle at 8, 8. And if we have a circle with a radius of 4, check it out, it ain't going to make it over here to the y-axis, right? So it's going to be this circle sitting in space. So answer choice A can't be right because it's got to hit the y-axis. All right, let's look at answer choice B. Radius is 4 again. What are h and k? They're 8 and 4. So we've already done 8 over. This time we're going to do 4 up. 1, 2, 3, 4. There's the center of our circle. Radius is 4. Are we going to be able to hit the y-axis? We're not. It's going to be a circle sitting in space. So B is gone. All right, so let's look at C. Radius is 4. H and K are 4 and 9. All right, 1, 2, 3, 4. We got to go up here. So in this one, it's going to be at 4, 9. Are we going to be, what's going to happen over here? We're going to go over here. We're going to go 4 over here. Hey, that hits the y-axis. How many times? Well, if you kind of make your circle, it's obviously not going to look like this, but it's going to look something. It's going to go 4 over here. And hey, man, this circle is going to hit 1 time on this y-axis. So that's the answer. D doesn't even make sense. It's not even in the right form. If you draw this out, it's not that bad. Get it right and move on. We're on SAT Practice Test 10, Math Section 2, Question 17. What's the level of difficulty here? It's hard. Got an equation. One of the equations in a system of two linear equations is given. The system has no solution. Which equation could be the second equation in the system? All right, we're going to write down what we're looking for. The important thing here is no solution. Guys, this problem is simultaneous equations. How do I know? Well, I got two equations. I got one here, and then in the right answer, I'm going to have another one. And then Evil Testing Service flatly tells us two equations. Simultaneous equations are always the same. We're going to stack them up, and then we're going to add or subtract. What does no solution mean? No solution means all the variables go away. So we are looking to stack the equations, add or subtract them, and then all the variables are going to go away. One wrinkle in this problem is that this equation is written in a different order than the answer choice equations. Let's fix that. Let's put this equation in the same order as the answer. So we're going to put the 6x across the equal sign. It's going to become negative 6x plus y equals 18. And now I've got this equation here in the same order as the answer choices. All right, I'm going to write A, B, C, D because I know I'm going to cross off. The other wrinkle here is answer choice A. Look carefully at it. Negative 6x plus y equals 18. Look at this. Negative 6x plus y is 18. That's the same equation. You don't have two equations. You just have one. You don't need to do anything with answer choice A. Can't be the answer. It's gone. Let's look at answer choice B. Let's stack them. Negative 6x plus y equals 22. I'm going to put a line under them. And then when I add or subtract, I'm looking always to make stuff go away. It's easy to subtract here because you can see that y minus y is what? 0y. Now let's see what happens here. Negative 6x minus 6x. That's negative 6 plus 6x, which is 0x. So you've got no x's, you've got no y's, you got no equation. And if you've got no equation, you got no solution. So B is the answer. That's it. That's all you got to do. Get this problem right and move on. If you want to do C and D real quick, fine. This is C. Again, I can see really easily that I can subtract, say y minus y. So the y's go away. That's great. Negative 6x minus 12x is negative 6x plus 12x. That's 6x. Did all my variables go away? They didn't. And if I go over here and I say 18 minus 36, that's negative 18. I've got 6x equals negative 18. I'm going to be able to solve this thing. So I don't have no solution. So that's gone. Let's look at D. D down here is exactly the same thing. Y minus y, that's 0y. Negative 6x minus 12x. That's negative 6x plus 12x. We already did that. That's 6x equals 18 minus 18, which is 0. Again, I'm going to be able to solve this. X is going to be 0. So I'm going to have a solution. So D is wrong. But you didn't need to do all that stuff. B is the answer, and once you see that it's the answer, you're done. We're on SAT Practice Test 10, Math Section 2, Question 18. What's the level of difficulty here? It's crazy, stupid hard. Which expression is equivalent to this giant mess? Guys, this problem's a plug-in. How do you know? It's got letters in the problem. It's got letters absolutely crawling all over the answer choices. This problem is also the plug-in from hell. But you can do it. You just got to move through it consistently. What should you plug in? Normally you want to plug in numbers that go with the numbers that are in the problem, but there's so many numbers in the problem, it's so complex, you should just use the easiest numbers possible. So I'm going to make x equal 2, I'm going to make y equal 3. So y plus 12, that's 3 plus 12, that's 15, over 2 minus 8, negative 6. I'm going to reduce, I'm going to divide both sides, or I'm going to divide the top and the bottom by 3. So it's negative 5 over 2 plus y times x minus 8. So 3, I'm going to do this over here, times what? Negative 6. So that's negative 18 over x squared, 4 times 3, that's 12, minus 8 times 2 times 3, 8 times 6, 48. So 12 minus 48, definitely do that on your calculator. That's negative 36. What's negative 18 over negative 36? That's a half. So you've got negative 5 over 2 plus a half. Not that hard. That's negative 4 over 2. And all of that is negative 2. Okay, already done a lot of work. What are we looking for? We're looking for negative 2. So circle it. And when you go to the answer choices, you're going to cross off all the answer choices that aren't negative 2. So I'm going to write A, B, C, D vertically. And I'm just going to put my head down and go to work. X times y, that's 6, plus y, that's 9, plus 4, that's 13, over x to the third is 8, times y is 24, minus 16 times 4 times 3. Obviously, calculator math, 192 plus 64 times 6. More calculator math, 384. All right, I'm going to go ahead and do this. 24 minus 192 plus 384. That's 216. So this is 13 over 216. You don't need to do anything else. It's obviously not negative 2. Go on. All right, B, x times y, 6, plus 9 times y, 27, plus 12. I'm going to add those up on the top. We get 45. And then on the bottom, x squared y, so that's 4 times 3, that's 12, minus 8 times 6, that's 48, plus 2 minus 8. That's negative 42. Top's bigger than the bottom, not going to work. So B is gone. All right, let's try C. X times y squared. 2 times 9, that's 18, plus 13 times 6, 78, minus 8 times 3, 24. Go ahead and plug that in your calculator. 72 over x squared y, that's 4 times 3, which is 12, minus 8 times 6, 48. 12 minus 48, we've done this one, we can do it again. That's negative 36. So now you're going to divide 72 by 36. Look at that. Negative 2. That's it. That's the answer. When you get to the answer, especially on something as complicated as this, when you find an answer that works, you're done. It's taken enough time. You know you're right when you leave this thing, and move on. We're on SAT Practice Test 10, Math Section 2, Question 19. What's a level of difficulty supposed to be here? It's supposed to be hard. Got an equation. The given equation relates the positive variables P, Q, R, and S. Which of the following is equivalent to Q? So we're looking for Q. Let's write it down and circle it. Guys, this is a plug-in. How do you know? Variables crawling up here, variables crawling all over the answer choices. Plug in anything you want when you plug in. Any numbers will work. But you should plug in numbers that are easy. What are easy numbers going to be here? They're going to be numbers that go with 20. I'm going to rewrite this thing. When you start plugging in, where should you start? You should start where math is happening. There's no math happening on the left side of this equation, but there's math happening on the right. So start on the right. I'm going to make Q 2. I want this thing to be big because I'm going to subtract things from it, and 20 and 2 go together. So it's 20 over 2. What's that? That's 10. All right, minus, what's something else that goes with 20? How about 4? R is 4. All right, so that's 20 over 4, which is 5. And what's something else that goes with 20? 5 also goes with 20. 20 over 5 is 4. 10 minus 5 minus 4, that's 1. 20 over P is 1, so what's the only thing that P can be? P's got to be 20. All right, I'm going to circle what I'm looking for. Looking for Q, so I'm going to circle Q equals 2. And I'm going to go to the answer choices, and I'm going to cross off everything that isn't 2. P plus R plus S, that's 20 plus 4 plus 5, that's 29. Nope, that is not 2, it's gone. 20 times 29, no, that's just some big thing that's gone. All right, things get interesting here, but not hard. P times R times S, so 20 times 4 times 5, that's 80 times 5, which is 400, over this big, huge thing, P times R, 20 times R, so that's 80, plus P times S, 20 times 5, which is 100, plus r times s, 4 times 5, which is 20. Do it on your calculator if you want. 80 plus 100 is 180, plus 20 is 200, so this is 400 over 200. And guys, anybody can see that that is 2. So C is the answer. You don't have to do anything with this. There's virtually no way that D is also going to be 2, but if you want, fine. 400 over, and then it's real easy, 20 times P. That's already 20 times 20, which is 400, plus something else. That's going to be a fraction. Nope. So C is the answer to this allegedly hard problem. If you plug in, you leave it knowing you're right, and it was very easy, and you move on. We're on SAT Practice Test 10, Math, Section 2, Question 20. What's the level of difficulty here? It's crazy, stupid, hard. This is the craziest, stupidest, hardest problem you're going to see on SAT Practice Test 10. You've got an equation. In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? So let's write down what we're looking for. Let's circle it. And then there's two other really important pieces of information. What are they? No solution, and k is an integer constant. That's vital. Start by writing the equation. Anybody can do that. And what should you do here? Just PEMDAS. Get rid of this parentheses. If you do that, you'll see you have a quadratic equation. X times kx is kx squared minus 56x. If you move negative 16 across the equal sign, it's plus 16 equals 0. What's the quadratic equation? It's ax squared plus bx plus c equals 0, and you have the same form. It's a lot to be said about the quadratic equation. You don't have to know a lot about it in SAT land. But the thing you really need to know is b squared minus 4ac. You got to commit it to memory or put it in your calculator. b squared minus 4ac can have three results. It can equal 0, it can be bigger than 0, or less than 0. If b squared minus 4ac equals 0, your quadratic equation has one solution. If b squared minus 4ac is bigger than 0, your quadratic equation has two solutions. If b squared minus 4ac is less than 0, your quadratic equation has no solutions. So that's what we want. We want b squared minus 4ac to be less than 0. So b squared minus 4ac, write it down here, and then just plug and chug. It's negative 56 times negative 56. That's obviously going to be positive. You're obviously going to do it on your calculator. It's 3,136 minus 4 times a is k times c is 16. All right, here's some dirty math. I'm just going to make this equal to 0. See what happens. See what happens if I have one solution. So it's 3136 minus 64k equals 0. I'm going to move the 64k across the equal sign so it's positive. Simple algebra, 3136 equals 64k. Divide both sides by 64 on your calculator. And if you have one solution, then k is 49. But you know you don't have one solution. You have no solution. So we need to get it less than 0. The easiest way to do this is just to see what would happen if you make it less than 0. Let's make 3136 minus 64k less than 0. Don't think too hard about it. What's something that's less than 0? How about negative 2? If we do this math, I'm going to move the 64k to the right. 3136 plus 2 is 3138. I'm expecting a really nasty decimal. 3138 divided by 64, k is 49.03. All right, say that doesn't help me. Fine, make something else that's less than 0. We're running out of room here. How about 3136 minus 64k equals negative 10? If I do that, again, 64k goes over here. 3146, divide both sides by 64. I'm expecting another nasty decimal. And that's what I get. I get k is 49.15. How does this help me? It helps me because k has to be an integer constant. That is critical information. K is an integer constant. I plugged in negative 2. I got a little bit more than 49. I plugged in negative 10, I got a little bit more than a little bit more than 49. So what's the next integer constant that k can be if I have no solution? It's 50. It's just the next integer up. And that's the answer. This is a hard problem. There's no two ways about it. I do the SAT 1500 club. I don't do the 1600 club. If you get this wrong, there's no shame in that. You get a 780 math, go home happy. We're on SAT Practice Test 10, Math Section 2, Question 21. What's the level of difficulty here? It's hard. For a lot of people, it's going to be crazy, stupid hard, but not for you, because you're going to plug in. Got two equations. For each real number r, which of the following points lie on the graph of each equation in the xy plane for the given system? All right, first of all, there's simultaneous equations going on here. How do I know? Because I got two equations. Simultaneous equations are always the same. You're going to stack them up and then add or subtract. Draw a line under the equations. Your goal when you add or subtract is to make x or y go away. Adding or subtracting these equations won't do that. So what you do is you multiply one of the equations or divide one of the equations by something. Here I'm going to multiply this one by 5 because I can see that I can get to 10x. And when I do that, I get 5 times 2x is 10x plus 5 times 3y is 15y equals 5 times 7, 35. Holy cow. I don't have two equations after all. They're the same equation. So I'm just going to write one of the equations down since they're the same one. Should I use the easy one or the hard one? Let's use the easy one. All right, this is the plugin. How do I know? Because the answer choices are crawling with r's, letters. Evil Testing Service says nothing about there being a constant. So I can make up any r I want in the whole wide world, and it will get me to the answer. Should I use an easy r or a hard r? I should use an easy r. My first inclination is always to make r 2, because 2 is the easiest number in the whole wide world, but then I see I'm going to have 2 over 5. I don't want that. So I'm going to get a number that goes with 5. I'm going to make r 10. Why didn't I make r 5? Because then I get 5 over 5, which is 1. And I really want to avoid 1s and 0s in any form and any plugging in, because it might make more than one answer look right. All right, if r is 10, all I'm going to do is plug in the answer choices. And the thing to understand here is that these answer choices are just x and y. All right, so r is 10. 10 over 5, that's 2 plus 7, that's 9, negative 33. All right, so 2 times 9, that's 18, plus 3 times negative 33, that's negative 99. That's not 7, so it's gone. All right, let's try B. Negative 3r over 2 plus 7 over 2. Looks really nasty, but it is not that bad. 3r is 30 over 2, so it's negative 30 over 2 plus 7 over 2. What is that? Denominators are the same. I'm going to put it over here. It's negative 23 over 2. And then r is y. That's just 10. So 2 over 1 times negative 23 over 2. Look at this. These 2's reduce away. It's just negative 23 plus 3 times 10, that's 30. What's negative 23 plus 30? Put it in your calculator if you must. It's 7. All right, guys, that's it. That's the answer. As long as you plug in smart numbers, think about it for a second. You're on number 21 here. We probably don't have a ton of time. Don't waste a bunch of time doing C and D. You can if you want. They're not going to work. B's the answer. You get this problem right. You get it fairly quick. You know you're right when you leave. And it is crazy hard for everybody else, but not hard for you because you plug in. We're on SAT Practice Test 10, Math Section 2, Question 22. What's the level of difficulty here? It's hard, but it's not nearly as hard as some of the questions that just preceded it in this Section 2. A window repair specialist charges $220 for the first 2 hours of repair plus an hourly fee for each additional hour. The total cost for 5 hours of repair is $400. Which function f gives the total cost in dollars for x hours of repair? X is bigger than or equal to 2. So let's just write down the basics of kind of what we know here. it's $220 for 2 hours, then there's an hourly fee. X is bigger than or equal to 2. If you bust out a window at your house and your parents make you pay for it, you're not going to set up a function. You're going to call the window guy. You're going to say, what's it cost for me to get this fixed? He's going to say, well, it costs $220 for the first 2 hours, and there's an additional fee. How would you figure out the fee? You do not need to do this. I'm going to show you why. But how would you figure out the fee? If the first 2 hours is $220 and $400 is for 5 hours, you take 400 minus 220. Do it on your calculator. You get 180, and you say, well, how many hours left after $220? It's 3 hours. And so you could say, well, the hourly fee is $60. You don't really need to know that. You can just plug in here. You can plug in and be really, really lazy. Why not just make X equal 5? If X is 5, what's it cost? It costs $400. So I'm going to write ABCD. I'm going to do it vertically. And I'm just going to plug in 5 every time I see an X. 60 times 5, that's 300, plus 100. Hey, that's 400. Should I just pick it and move on? No, because I was so lazy here. I'm expecting more than one answer choice might look right, so I'm going to do them all. 60 times 5, that's 300 plus 220. You can ballpark this out. That's clearly not going to be 400, so it's gone. 80 times 5, hey, that's 400, but I was expecting that because I was lazy. 400 again, 80 times 5 plus 220, ballpark that out, that's not going to be 400. All right, so I'm down to A and C. What should I plug in the second time? Well, how about just 2? X is 2, what's it cost? $220. All right, let's try it out. So 60 times 2, that's 120, plus 100, that's 220. I don't have to do B or D. 80, this is C, times X is now 2, that's 160. That's not 220. So it's gone. The answer is A. You can plug in and get this problem right. It is a gift at number 22. You get it right. Congratulations. You are done with SAT Practice Test 10.